Hello! In this unit we will continue our discussion about sets. The topics covered in this unit include the concept of equality between sets and the relationship of inclusion between two sets, therefore the concept of a subset. The essential knowledge to continue with this unit is a clear understanding of the concept of a set. Despite the fact that looking at the concepts of this unit, we will review the previous ones. Well, when do we consider two sets as being equal? We say two sets as equal when they have exactly the same elements. The elements found in one set are also present in the other, and vice versa. Let's see this with a graphical example using Venn diagrams notation. The Venn diagrams represent here two sets, set A and set B, as we can see in the representation. Set A consists of four elements, represented by four colors, or we can view them as four words: blue, red, green, and yellow. On the other hand, set B is a different set that also has four elements that are red, yellow, blue, and green. Initially, these are two distinct sets, and the definition states that they are equal if the elements in one set are exactly the same as those in the other set, and vice versa. We can check this equivalence by inspecting the sets. In the first place, we examine the element red and inquire whether this element is also present in set B, and as we can see, we confirm its presence in the other set. We proceed and we observe blue. Is blue present in the other set? Yes, it is. We continue the testing process with green, and it is indeed in the other set. Lastly, we consider yellow, and we find that yellow is also a member of the other set. Then, the elements that belong to set A are precisely the same as those in set B, and vice versa. No elements are unique to either set or belong to one set, but not the other. Consequently, we can conclude that the sets are equal. Observations. As we've mentioned in earlier videos, the order of elements within a set is not significant. This principle is evident in the Venn diagram representations. There are four elements, but it's not clear which is the first or the second. They do not have a specific order. They are simply objects within a collection. An important aspect is that an object within a set either belongs to it or doesn't, but it cannot exist in multiple instances within the same set. We cannot have blue appearing twice within a set. It's present or it is not. It's crucial to be careful when applying the definition of equality. For example, if I remove blue from set B, the sets are no longer equal, as A now contains an element that B does not. However, there are other scenarios where equality is violated, such as when, instead of removing blue, I replace it with orange. Now, set B includes a color that is not present in set A. Although both sets still contain four elements, they are distinct because B now has a color that A lacks, and vice versa. The concept of inclusion is very important. When we state that one set is included within another, we are essentially asserting that set A is included in set B when all the elements of set A are also elements of set B. We do not need all the elements of set B to be in the set A, as is the case with equality. In the concept of inclusion, it's enough that all the elements in set A are also elements in set B. The notation we use for this is an elongated C-like symbol, which is called inclusion. And when set A is within set B, it is referred to as a subset of B. This represents the concept of a subset. Inclusion and being a subset are essentially synonyms. Let's examine this graphically. We have two sets, set A and set B. We've drawn set A slightly smaller in size, but this doesn't necessarily imply that it is included in B initially. Let's remember that being included means that the elements of one set are present in the other set. To establish that A is included in B, we examine the elements of A, which are red, orange, and yellow, and verify that each of these elements are indeed present in set B, red, yellow, and orange. In this case, it doesn't matter if B contains additional elements. What's crucial is that it contains precisely the elements found in A. Having more elements does not affect the inclusion. We say that it's included. What is included can be expressed in a more colloquial way by saying that A resides within B, or that all the elements of A are within B, or simply that A is inside B. Although it is stated as a property that A is included in B, in reality, A is an entity in its own right. It is a set that exists within another set, which is set B. Well, by the end of this unit, we should be capable of determining the equality between sets, given two sets, see if they are equal, and recognizing when a set is a subset of another, or, giving a set, identify which are its subsets. This is all. Thank you.